Hello everyone, welcome to Try and Design. In today's video we are going to install reinforcement in a rectangular beam. So first of all we will select this beam, go to Navigate Extension and select Beams. As you can see in the geometry section we have every necessary information and the dimensions for our beam. So let's start with stirrups. And first of all we will discuss stirrups parameters. This is the main stirrup, basically the covering stirrups of a beam, and if we want to install the anti-shrinkage reinforcement we can just check this one and set up the anti-shrinkage reinforcement. So let's move to the main topic, the stirrups parameter. So we are going to use number 3 rebar, and the stirrup type we are going to use this type because our beam is wide beam and we are going to use the double stirrup reinforcement. And for the spacing between two rings, which is given as A, as you can see, the distance between two legs of the adjacent rings, we are going to use 10 inches in this area, and we will also install the anti-shrinkage reinforcement for our beam. So we are going to use number 4 bar with number 3 stirrups. In the stirrup parameter we have set up everything as our requirement. Let's move to another one, stirrup distribution. So we have 3 spans and we have a retaining wall on one corner and a cantilever portion on the other side, and one regular span in the middle. So in order to understand, you have to learn, or you should have the knowledge of structural reinforcement as mentioned in the code 315-99. I will also put the link in the description below. And let's set this distribution type as this one. So we have two sides with congested rings and the between area will be the regular rings. So as you know, we have to install the congested rings from the end, from the extreme support. We have to install 0.25 into L dimension, and on the column support we have to install 0.3 into L. Here L is the clear span, which is 23 in this case. So we have to calculate L by 3, which means 0.3 into L. Normally in the Navigate Rebar extension, and Navigate automatically adjust L by 3. But if you want to calculate as per your requirement, you can just, let's write 23 into 0.3. So this will be 6.9 feet. So we have to install 6.9 feet from the column, 6.9 feet, and from the other side, which is the extreme left support, we have to install 0.25 into L. So here L is 23, which will be multiplied by 0.25, and this will be 5.75. So we have to write 5.75 feet. So the dimensions are set, and we have to write the spacing between the reinforcement. The S1 will refer to the congested rings on one side, S3 will refer to the congested rings on the other side, and S2 referring to the middle area. So we have to install 4 inches from both side congested rings, and between this congested rings we have to install as per 9 inches. So once you write the desired dimensions, the preview will be set automatically. Now we will talk about DL and DR. The DL and DR is the distance from the edge of extreme support to the first ring. So normally this will be the half of the spacing between the rings. So we will write 2 inches. We write 2 inches on both sides. Now this one we have the example for the span, normal span. And the one thing which need to be discussed is the stirrup distribution above the extreme support. So we have the left extreme support of the retaining wall. If you want to install additional rings on that support, we have to write some dimensions on this area. The AL is basically the distance after which you have to install the rings. This will be 6 inches in our case, and SL is basically spacing between rings. So we will write 3 inches. We have also installed the rings on extreme support. Let's move to span number 2. Here we will also install the reinforcement as the previous one. So I will speed up the video. So we have set everything in the span number 2. Now let's move to span number 3. This is a cantilever portion. So we just use the normal distribution type, and we will choose the spacing as 4 inches. And for the DL we will write 2 inches, and for DR we will also write 2 inches. Let's move to the bars, main bars. We have two types of main bar, lower bar and the upper bar. So first of all, we will set the dia. We have to place number 6 bar, and we have to place 4 bars on bottom, and we have to place number 6 bars and 4 bars on top. So the LA and LB is basically the development length. So we have to write 9 inches. Basically, as per codes, this should be 12D. So minimum should be 9 inches. And the other side we will also write 9 inches, 9 inches. Now the bottom and lower and upper bar is set, and for the additional top bars we have to install the top bars on span by span. So let's move on to span number 1. You can also change the span number 1 from the top area, and you can also set the span number by selecting in this preview. So we have to install the extreme left support, and we have to write. So as per the codes, we have to install this reinforcement as 0.25 L, which is 0.25 multiplied by the clear span, which we need to calculate as there 23 into 0.25. This will be 5 feet and 9 inches. This is already set, and we have to write 9 inches for the development length. Next, we have to install the top reinforcement on span 2. We have the left side support, and we have for the right side support we will install the reinforcement on cantilever side, which will be discussed further in this video. And for the reinforcement diameter, we will install number 8 bars as our top additional reinforcement, number 8 rebar. And for the numbers, you cannot change this one below 3, because between two main rebars you can install one additional rebar, and between 4 main rebars you can install three additional reinforcements, or the double of 3, which will be 6. If you change, you will get 6 or 3. So let's write 3 for now. And for the dimension on left side and dimension on right side of this support, so 23 into 0.3, this will be 6.9, and 22 into 0.3, this will be 6.6. We have to write 6.9 and 6.6 feet. So this will increase. For span number 3, we have to install the reinforcement, additional reinforcement from this corner up to the other side of this support. So in order to calculate this one, we have to write length of cantilever portion, which is 9.42, and plus multiply by 1.5, which will be 14, plus 9.42. So the length of cantilever multiplied by 2.5 is the length of additional top reinforcement on the cantilever side, which will be 23.55. So we will check this one, and we will write 23.55 feet on this side. As you can see, our rebar is extending up to the center of the next span. Write 9 as our development length of this reinforcement. So the top reinforcement is completed. Now move on to next topic, additional bottom rebars. Same as this one, we have to install bottom reinforcement on the extreme left support. For the length of rebar, we just need a clear space from column to the end point of the bottom additional reinforcement. This must not exceed 0.125 into clear span length. So the clear span is 23 into 0.125. So this will be 2.875, round up 3 feet. So we have to end our bottom additional reinforcement before 3 feet of this column. So let's write this is 23, so 3 feet will be reduced and 2.6 feet will be added. So this will be 22.5 feet. Let's check this one if this is okay. This is not okay. Basically this should not be 22, this should be 20. This will be exactly 20 feet. So then we have 3 feet of gap between the column and the additional reinforcement. Next up, in the span number 2, we have to install the bottom reinforcement span bar. So this will be a span bar, and the same rule applies on this area. Uh, we have to make a gap for between the bottom additional reinforcement and the column. So let's check this one. If this is 5, 6, then we have to write 2.5. So this will be 8 feet. Yes, this will be 8 feet. So the remaining is 3 feet. This will be 8 feet. And for span number 3, we don't need any bottom additional reinforcement because the cantilever side acts differently from the supported beam. So this just need only this only need the top reinforcement. The top reinforcement should be more in the cantilever portion. Now move to the bar division area. Here we will distribute our bar length because we have 63 feet long main bottom and top reinforcement. So we have to distribute in pieces because normally the factory do not produce bar length more than 40 feet or maximum 45 feet. So we have total length of beam is 63 feet, also adding development lengths. So we have to distribute the rebar, but the distribution should not be done as per actual condition outside. This should be done as per the codes, ACI codes, which defines that the top main bar should be terminated mid of the beam, and the bottom reinforcement should be terminated or overlapped on top of supports. So let's check this one. Division of main top bars, we will check this one. Now you have the information, our L max which factory normally produce, this will be 40 feet. And the coefficient, this is basically overlap or splicing length. As you can see in the sketch given, we will just write 60D because our overlap length is 60D. You can also determine the length of the overlap, or you can just write coefficient. As you can see, our main bar is number 6 bar, and the 60D is 3 feet 9 inches. 3 feet 9 inches, 3 feet 9 inches, and so on. Now our top reinforcement is distributed in pieces. We have overlap on every midpoint of span. And for the main bottom bars, we will also write 60 feet coefficient. You can also write length in here also, and you can write 40 feet, 45 feet, maximum 45 feet also you can write. You just have to remove this one and you can write 45 feet. Reinforcement setting in the beam is completed. We can thoroughly check every information. So we have main bars, bottom bars, top bars. We have every information. We have given every information except this one. I think we didn't give the information. Okay, this is correct. For the bottom bars, let's check on span number 3. We do not have bar division. This is okay. Now just click OK. And this will generate the reinforcement in beam. Now that we have created the reinforcement in beam, we cannot see that reinforcement in this beam. So we have to make it visible. We have to select all the things in our drawing, go to filter, check none, and select structural rebar, and then apply and click OK. So the rebars will be selected only. And in the properties panel, go to graphics, view visibility state, click on edit, and in front of 3D view, just check view unobscured and view as solid, and then click OK. In order to view this one, you have to set the detail levels to fine, and then you have to set this one to realistic. Let's go to shaded. Now as you can see, the reinforcements are placed very neatly. Now it's time to name these rebars and to prepare a rebar schedule for our beam. Let's go to view and then click on schedules and click on schedules and quantities. Now we will find structural rebar. We'll find structural rebar. We'll write the name of our rebar schedule and beam schedule, and then click OK. Now we have to add all the required components. These are the major items which we need to include in our rebar schedule, and we have to make some new parameters, which is unit weight, and this will be a type instance, and this will be type, and structural discipline, and will be mass per unit length. And we have to add a formulated parameter, which will be the total weight, and discipline will be structural, and type will be mass, and we have to multiply total bar length with unit weight. We'll click OK. Now we need to add images. We will add image, then click OK. The bar bending schedule is ready. We need to add unit weight for this one. For every dia we need to add the unit weight. The unit weight of dia number 3 will be 0.376, and this will be a type parameter, so all the number 3 rebars will be added. And for the number 6 we have 1.502 pound per feet, and for the dia number 4 we have 0.668, and that's it. We have to add sorry, for the number 1, for the number 1 inch number 8 we have to write 2.67, and for number 4 we have to write 0.668. You can set the unit styles and everything like this one. If you want to change the total weight unit, you can go to format unit, uncheck choose per project setting, and select kilograms or tons. Let's select kilogram, and let's select OK, and that's it. So we will go to sorting and grouping, and we will uncheck itemize every instance, and we will select sort by total bar length, and in the filter area, sorting area, we will check grand totals and click totals only. In the formatting area, select total weight and select calculate totals, and then click OK. So the total weight of our beam reinforcement is approximately 1 ton. And if you want to add this rebar schedule in your sheet, you can add it, but first we will add some images in our drawing. So these are the top bars. We have to add reinforcement drawings images. We have some images in our desktop. We'll select these. We will select this one, and for rings we will add this one, and for the anti-shrinkage rebar, this I am giving just an example. For the full setting of these images you can refer to the other video. I am placing the link in the description. You can check that video out. And let's create a sheet. On the project browser panel, in the sheets, right click, select new sheet, and we will load let's load A3 size paper, and open this one. And for placing the schedule inside this sheet, you just need to drag the beam schedule in this sheet and just place. And if you want to make it smaller, you can place it inside the sheet and just adjust the size, and that's it. We can adjust the sizes of our rows like this one, and this setting will be applied to the reverse schedule in our sheet. As you can see, we have placed like this. So I hope you enjoyed this video of beam reinforcement. If you really enjoyed this video, share it with the others for the learning purposes, and like this video, comment, share your suggestions in the comment section, and see you in the next one.